The weight of a ship is called its displacement, and this is measured in tons, metric tons of 1,000 kilos. The displacement is made up by the empty ship, we call this the light ship, and all the weights that we put on board it. Fuel, water, spare parts, cargo, fishing equipment, crew, provisions, etc. All these weights are called dead weight. That's what we put on board the ship. So displacement equals light ship plus dead weight. When the ship is built, you do an inclining test to determine the center of gravity of the light ship. And this center of gravity for light ship will be found in the stability data and is also an important factor in all the conditions and all the calculations that are made for the vessel. The center of gravity of the ship and all the weights that are placed on board we can find by putting up a table and calculating the moment or the torque for every single weight. So we put a lot of different weights on board the vessel and we can easily calculate the center of gravity for the ship with all these weights. Moment equals weight multiplied by arm, where the arm is the kg for the specific weight, and we will see how this is done. And then the new kg is sum of moments divided by sum of weights. An example, we have the ship before loading had a displacement, a weight of 100 tons with a kg of the vessel, 2.6 meter, and then we put on board 3 different weights. What is the G afterwards? Well, before loading we had a moment of 260 ton meters. We take on board cargo number 1, 30 tons by 1.2 meters, which gives us 36 ton meters. Cargo number 2, which was 22 tons and a kg of 2.5 meters, gives us a moment of 55 ton meters. We have cargo number 3, which was 5 tons and a kg of 5 meters, which gives us another 25 ton meters. Then we sum the weights and we sum the moment, and the new kg, the new vertical center of gravity, is sum of moments divided by sum of weights. So 376 ton meters divided by 157 tons gives us a kg of 2.39 meters. So we see before loading the kg was 2.6 meters. After loading it's gone down to 2.39 meters. A working task, we have a vessel Kystfart with a displacement before loading of 210 tons and a kg of 2.2 meters. Then they take on board a deck cargo of 24 tons with a kg of 3 meters. Then what is the kg for Kystfart after loading? Well, 210 tons multiplied by 2.2 meters gives us 462 ton meters. The new deck cargo, 24 tons, kg 3 meters, gives us a moment of 72 ton meters. Some moment, 534 ton meters. Some weight, 234 tons, which gives us a new kg of 2.28 meters. So we see in this case the center of gravity of ship and cargo has moved upwards when we loaded the deck cargo. For discharging it's pretty much the same, except that we have to use a minus. A ship has a displacement of 550 tons before discharging and a center of gravity of 3.06 meters. Then we discharge 100 tons from the cargo hold. The cargo hold has a kg of 2 meters. So we discharge that, and then what will the kg for the entire vessel be after discharging? Now when we discharge weights we use a minus for the weight in the table, as we will see. Put in the table and we see the discharged weight lost i rommet minus 100 tons. So we do the calculation and gives us a moment of minus 200 ton meters. This again gives us a displacement after discharging of 450 tons, a moment after discharging of 1,483 ton meters, and the new kg is then 3.3 meters. So we can see that the center of gravity of ship and cargo has shifted upwards after discharging, which is logical since the discharged weight was fairly low down in the hull. Summarizing, adding and removing weights. When we add a weight above G, G shifts upwards. When we add a weight beneath the center of gravity, then the center of gravity will shift downwards. When we remove a weight above G, then G will shift downwards. And when we remove a weight underneath G, then G will shift upwards again. And this is, of course, very logical. Kg, center of gravity for the vessel, is sum of the moments divided by sum of weights after loading or discharging. So far, we have made a table, added or removed weights, calculated moments, and then summarized to find the kg. There is another method which is suitable when you are moving weights on board a vessel. We call this the formula method. And the formula looks as this: G1 equals weight multiplied by arm divided by displacement. And GG1 means how much G of the entire vessel moves as a result of moving of one individual weight. So we move the yellow box from the deck level down into the hold, and GG1, that is how much the G of the entire vessel shifts. We will look at an example. We will calculate how big is the effect on kg if you move a 3-ton fishing net from deck and down into the cargo hold. We're assuming that the GM is 0.4 meters, the displacement is 750 tons, and the vertical distance between deck and the cargo hold is 5 meters. So we're shifting 3 tons downwards 5 meters. How much does then the G move? We put into the formula 3 tons by 5 meters divided by 750 tons, and that gives us a GG1 of 0.02 meters. So we see that G moves down by 2 centimeters when we do this weight, which means that the GM will be 2 centimeters bigger. So it goes from 0.48 meters to 0.5 meters. Another example, we have a GM of 0.39 and we want to move an old compressor from a lower deck and onto upper deck to put it ashore. The weight of the compressor and its equipment is about 2 tons and the vertical distance is 4 meters. The displacement of the vessel is 245 tons. What is the GM if we move the compressor up? So, how much does this move affect the G of the entire vessel? We put the numbers into the formula: 2 tons by 4 meters divided by 245 tons, which gives us 0.032 meters. The GM was 0.39. We're moving a weight upwards in the vessel, which reduces the GM. So we end up with a GM of 0.358 meters. This is just within the requirements if we're a fishing vessel, where the minimum requirement for the GM is 0.35 meters.